Hello everyone! Today I will be showing you how you can make a relatively high voltage using only a mains transformer. Now why exactly a mains transformer and not something like a smaller flyback transformer that you might find in switch mode power supply? Well, the mains transformer has a very high inductance, or its windings have very high inductances. In fact, I can measure that right now, get out the component tester, and then measure the inductance of the high voltage side. If I connect that up right there, and hit start, let's see what the inductance is. That didn't work. Try again. Okay, it says that it's an inductor with an inductance of 3.6 Henry approximately and a resistance of 120 ohms. And if we measure the other winding, it only has a inductance of 0.3 Henry and a resistance of only 1.8 ohms, and that'll be very important later. So I'm going to put this tester away, and I've got this little circuit built up. Let's remove this wire for now. And if I hook up this, the high voltage side across here, and then turn this thing on, and press this button over here, I feel nothing. Hold on. Okay, I got it working again. I'm just using the wire inside the switch. If I tap this over here, then I feel a little bit of tingling in my fingers as I do this. And in fact, if I replace my fingers with this little neon indicator bulb, and turn out the lights, you can see every time I do it, it flashes. But only one side is flashing. If I want to do it properly so that both sides flash, I'll have to put a capacitor in series with the LED, which will filter all of the DC, and you should be able to see that both sides are flashing instead of just one side. Hopefully you can tell the difference. You might not be able to. Oh, anyway, I'm only using the high voltage side of the inductor, but what happens if I use the low voltage side? So, let's hook this up, and then get my little neon, and put it up between there. Let's have the capacitor too. And now, if I pulse it, it's still generating high enough pulses to arc, but now that we're doing the low voltage side, the transformer, being a transformer, will step up this voltage into a very high voltage that is actually high enough that if I hold these together, you can get a very faint arc. Maybe if I remove the neon too. Yeah, there's some crackling, and there's a tiny arc happening right in between those two wires right there. Every time that I do that, there's a tiny arc that you might not be able to see, but I can see it, and you might have been able to see it too. But anyway, let's see what happens if I shock myself with this. Oh, that hurt. This is more of a, it has a decently high power, and in fact, if I connect this right there, connecting one side to ground, and get the capacitor and the neon indicator, well, I'll just grab a new one from my bin, and hook that up, then we get some pretty nice bright flashes over there. You might be able to better see it over there. Never mind the bright green light, that's just the light of my power supply. I can cover it for you. Yeah, you get a little bit of flashing over there, but I want to measure this voltage. One moment, please. Okay, so I have Owen the oscilloscope set up over here, and if I hook up Owen's probe, the ground of the probe, to the ground of the supply, just by hooking it up through some sort of wire or something, and then measure the voltage right here, and then give it a little pulse. Put it into single shot mode too. It's ready, so now let's give it a pulse. There is a lot of stuff going on over here. So what's going on, you see this big graph over here. What's going on over here, let's get a pointer, is that over here there's just a little bit of stuff going on. But then over here, you get a, the wire briefly touched it and the voltage built up, but after the voltage built up, it immediately disconnected, and then there's a little bit of ringing due to straight capacitance, and then a similar thing happened over there, but for a very short period of time. But then it connected up fully and got time to build up to the maximum voltage, and then it eventually slowly died off from there. And in fact, let's measure what that maximum voltage was. This probably isn't the most accurate thing ever, but according to the trigger thing over there, that maximum voltage was something like 240 volts. That's double the mains voltage here in the United States, and basically the exact same thing as the mains voltage in Europe and in most other countries. So I managed to create a pulse, a pulse, mind you, very short pulse, of 240 volts, and in fact that's why it hurts so much, because this is a relatively high power thing. And if I could get this thing to switch with a relay, then I could create a relatively stable high voltage. And it's also why the relatively high voltage, I can cause some small arcs. That's about it for the day. Bye-bye.